we go. 6.2b, exponential growth and decay. I'm sorry for clapping in the speaker. All right, I need some readers up in here. And Doug's going to read.
Suppose an experimental population of fruit flies increases according to the law of exponential growth.
All right, when we see exponential growth, what do we think of? Y equals CE to the KT. All right, keep going.
There were 100 flies after the second day.
All right, let's stop there. 100 flies after the second day. What ordered pair does that make? 2, 100. All right, keep going.
Of the experiment, and 300 flies after the fourth day.
All right, what ordered pair?
4,
300.
Approximately how many flies were in the original population?
All right, so what are we trying to find?
C.
0, comma, question mark. That's what we're trying to find. We're trying to find C. All right, let's do it. So now we have y equals CE to the KT. So let's substitute in what we know. So let's use our first ordered pair. So now I have 100 is equal to CE to the 2K. Can I go much further than that right now? Not really, so I'm going to leave that alone for just a sec. All right, let's do the next ordered pair. So now I'd have what? 300 is equal to CE to the 4K. Can I do much with that right now? Not really. So we need to figure something out. Well, we can kind of solve for C in one of these. Agreed? What's C and E's relationship right now? Multiply, so we're going to divide. So C is equal to 100 over e to the 2k. So now I'm going to take that and do what? Substitute it back into this other one. So now we have 300 is equal to 100 over e to the 2k times e to the 4k. Well, what do we do when we have e to the 4k over e to the 2k? We subtract those exponents. So now we end up with 300 is equal to 100 e to the 2k. Now I need to start solving for k. So how do I do that? First I do what? Divide by 100. So then I get 3 is equal to e to the 2k. Then what? Natural log then? Divide. So k is equal to natural log of 3 over 2. All right. Now, it says approximately how many flies were in the original population. So basically, I'm solving for what?
0.
C.
I'm solving for C. So now I can take this and do what? Substitute in right there. All right, you can use a calculator if you'd like. This one doesn't actually need a calculator.
Oh, 33 repeated.
Yeah. All right, so we actually end up with C equals 33.3 repeating. However, to make sense of the problem, how many flies were in the original population, can I actually get that? No. So how many flies can we say? 33 or 34. All right. Honestly, it depends on how we look at that problem. Pretty good? All right, let's keep moving. Here we go. We got another one. Let's have Riley read.
4 months after it stops advertising, a manufacturing company notices that its sales have dropped from 100,000 units per month to 80,000 units per month. If the sales follow an exponential pattern of decline, what will they be after another 2 months?
All right, fantastic. So we need to make some ordered pairs. What would be my first ordered pair? 0, 100,000. Exactly. Then what would be my next ordered pair? 2, 80,000. All right. Then what? Oh, it's not. Yeah, it's 4. Why did I say 2?
Because it asks what it will be after
All right.
another 2 months.
All right. So this would be 4, because it's after 4 months. All right. And then what would be my next ordered pair? 6, question mark. That's what we're trying to find. All right. Because it's an exponential pattern, that jumps to what? Y equals CE to the KT. All right. Another word that we can jump there is called proportional. All right. So let's start substituting in. What does this basically mean?
That's C.
C. So C is equal to what?
100,000.
100,000. All right. So now I end up having y is equal to 100,000 e to the kt. So now we're going to substitute in our next ordered pair. So what would be my y? 80,000 is equal to 100,000 e to the 4k. So now what do? Divide by 100,000. And then what? We natural log. So now we have natural log of 0.8 is equal to 4k. So then what do? Divide by 4. So k is equal to natural log of 0.8 over 4. All right, from there, what do? Take that and substitute it back in. So now we'd have y is equal to 100,000 e to the natural log of 0.8 over 4 times t. What do we need to try to do now? Substitute in 6. Substitute in 6. All right, so then get out your handy dandy calculator. All right, and what do we get?
71541.7528.
You don't
Wait, what?
We don't need 7528.
No. 1753.
All right, fantastic. All right, however, which one do we need? 71,554. All right, that would be good. All right, let's keep. So now we're going to do Newton's law of cooling. All right, it's very similar to what we've been doing with y equals CE to the KT. However, it's going to take in the temperature in which the surrounding area is. That's all the difference of it. All right. So Newton's law of cooling is going to basically be like y minus the temperature is equal to CE to the KT. That's really what's happening here. All right. Now, I don't actually do it that way. I like to work smarter, not harder. So I'm actually going to do it like y is equal to, I always like to move that over. So then I'm going to say what? The temperature and then plus CE to the KT. Are you following me? All right. All right, so let's go on this one. I need a good reader. Thank you so much, Elijah, for volunteering.
Let Y represent the temperature in Fahrenheit of an object in a room whose temperature is kept at a constant of 60 degrees. If the object cools from 100 degrees to 90 degrees in 10 minutes, how much longer will it take for the temperature to decrease to 80 degrees?
All right, fantastic. So, what is my constant temperature of this room? 60 degrees. So now I end up having y is equal to 60 plus CE to the KT. Now, just like before, I'd like you to write out your ordered pairs. What ordered pairs should I have here? 0, 100. And then what would be my next ordered pair? 10, 90. And then what would be my next ordered pair? Question mark, comma, 80. And we'll talk about that in a little bit because the question mark is not actually the answer to this question. All right, we'll talk about that soon. So, just like before, we just start substituting in. All right, so what's my first y value I can substitute in? 100 is equal to 60 plus CE to the 0k. All right, and so 0 times k is 0, e to the power of 0 is 1, so I end up getting c is equal to 40. Guess where students sometimes go wrong on this? They say c is 100. All right, just because they're used to the other one. However, you have to worry about the temperature of the room or area that you're in. Does that make sense? All right.
It's right across the road, actually.
We have c equals 40, so let's substitute it back in. So now we have y is equal to 60 plus 40 e to the kt. Well, we solved for c. Now what do we need to solve for? K. So let's substitute our next ordered pair in. So now we have my y of 90 is equal to 60 plus 40 e to the k times 10, or 10k. All right. So what's my first step? Subtract 60. And then do what? Divide by 40. So what do we have over there? 3/4. So now we have 3/4 is equal to e to the 10k. Then what? Natural log, and then what? Divide by 10. So k equals?
Natural log 0.75 over 10.
Good. All right, I'm cool with that. And then what do we do after we have that? Substitute it back in. So now we have y is equal to 60 plus 40 e to the natural log of 0.75 over 10t. So now what are we solving for? T. So now we're substituting in 80 for y. So now we have 80 is equal to 60 plus 40 e to the natural log of 0.75 over 10t. So what's our first step? Subtract 60. Then what? Divide by 40. So that gives me what? 1/2. All right. Then what do we do to it? We natural log it. Can we do all those steps at once? Okay. So then we have natural log of 0.75 over 10 times t. So then what should we do? Divide by that or multiply by its reciprocal. All right. So let's put that into our handy dandy calculator. And I end up with t is equal to, should be 24, right? 24.0942 minutes. However, that's not the answer. Why is that not the answer? It says how much longer. So what do we need to do with this? Subtract what? 10. We need to subtract 10 because that's the last time we took a temperature. All right, so now we subtract 10. So my answer is actually what? 14.0942 minutes. All right, pretty good. On this type of problem, I usually give it 5 points, and I'm going to tell you how I break it down. If you get C, you get a point. If you get K, you get a point. Okay, if you can put it back into the equation, you get a point. If you can get this t value, you get a point. And then if you get that part, you get a point. All right, but guess what happens if you miss C?
0.
Everything's messed up. Okay, I'm just telling you that's how it works. Pretty good? All right, write those out. 73 and 74. So in 21 through 28, that's just the y equals c to the kt, your ordered pair things. Pretty good. All right. However, on 27 and 28, if you look with me, what's not solved for right away? Your c. Your c is not solved for right away. So that's when you kind of have to do what we did on the fruit fly problem. Okay. And then keep looking with me on 43 through 47. Just like you did half-lives, now what's this one? It's time to double, all right? So on time to double, instead of having 1/2 equals e to the kt, then it would be what? 2 equals e to the kt. It's the same thing, except instead of a 1/2, you have a 2. Does that make sense? All right. And then on 64, that's one that's not having a C. And then 73 and 74 are Newton's law of cooling. All right, pretty good? All right, keep going.